Hello and welcome to our next video in our Similarity unit. We're going to learn two new ways to prove triangles similar, and that's going to be side, 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 and side, angle, side. First, we have our side, side, side similarity, and that says if the corresponding sides of two triangles are proportional, then the triangles are similar. So what that means is in my two triangles that I have here, if AB over RS, so that's one ratio, is the same as the ratio of BC to ST, and is the same as the ratio of AC to RT, so those are all three pairs of corresponding sides. If I can show that these ratios are equal, then I can say that triangle ABC is similar to triangle RST. All right, in example one, we're giving three triangles. And we're going to say one of these two triangles on the left here, triangle DEF, or triangle GHG, is going to be similar to triangle ABC. Now, in order to figure this out, we need to go ahead and test ratios. And we got to figure out which pair of triangles has the exact same ratios for all three pairs of corresponding sides. So let's start with ABC and DEF. Now when I make my ratios, I'm going to put ABC on top. I'm going to put DEF on the bottom, just so I'm consistent with this. Now the best way to do this is to compare. We'll put our smallest side from ABC with the smallest side from DEF, and so on and so forth. So if I look at triangle ABC, AB, which is 8, is going to be my smallest side. So that'll go on top of my ratio. And that's going to correspond with DE, which is 4, my smallest side on triangle DEF. So 8 over 4 is going to reduce to 2 over 1, and that's my ratio of those two sides. Now we move on to the one in the middle, our medium side length. So on triangle ABC, that's going to be BC, which is 9. And that's going to correspond to EF, which is 6, which is my second biggest. So 9 over 6 is going to reduce to 3 to 2. And right now, as we can see, the two ratios that I have for my first two pairs of sides are not the same. I've got 2 to 1 for my first pair of sides, and I have 3 to 2 for my second pair of sides. So since these don't match up, we can automatically cross this one out. This one's not going to work. We don't need to test the third pair of sides. All three ratios need to be the same. Since we just have two of them right now, and they're different, we can go ahead and cancel DEF out. It's not going to work. So then we'll move on and talk about the next one, GHJ. So again, it's good to kind of, from the start, let me know how I'm going to do my ratio. So ABC will be on the top, and then triangle GHJ will go on the bottom. And again, we're going to use the same method. So we'll start with 8, since AB is the smallest side on ABC. And that's going to correspond with HG, which is 16. That's the smallest side. 8 over 16 is going to reduce to 1 to 2. So here's my ratio of ABC to GHJ. Next, we'll take my next smallest side, which is going to be BC, which is 9. And that'll correspond with HJ, which is 18, which will reduce to 1 to 2. All right, so far so good. Our last ratio we need to check is going to be my biggest side from AB, which is going to be 12. And my biggest side from GHJ, which is going to be 24, which will also reduce to 1 to 2. All right, so we've gone ahead and we figured out all three of these ratios. So by side, 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 these two triangles will be similar to each other. And we can go ahead and write a similarity statement. It'll be triangle ABC is similar to GHJ, and all the corresponding parts match up. You remember we did AB with GH, so those two parts match up. BC with HJ, and then AC with GJ, so the similarity statement would be correct. All right, for example 2, we're given, we want to find out what value of x makes triangle ABC similar to triangle DEF. So in order for these to be similar, the statement of proportionality is going to have to work out. So let's start by writing the statement of proportionality. So ABC is similar to DEF. AB is going to correspond with DE. Okay, BC will correspond with EF. And then lastly, AC will correspond with DF. Now the next step is going to be to go ahead and substitute the values from my triangles into my statement of proportionality. So AB on my triangle is going to be x minus 3 over DE, which is 20, equals BC, which is 4, over EF, which is 10. And that's going to be equal to AC, which is 10, over DF, which is 2x plus 3. Now, in order to solve this proportion, we need to pick two of these three ratios and set a proportion with those. Now, we can pick any combination of ratios that we want to. However, there's probably going to be two combinations that might be a little bit easier for us. And that combination would be if I pick the first and the second ratio, or if I pick the second and the third ratio. If I put together the first and the third ratio, we can still solve this. We'll have to do a distributive property and end up factoring to find my answer, which again is not wrong, but it's just maybe a little bit longer way to solve this problem. So I'm going to go ahead and choose the first two ratios, and that's how I'm going to go ahead and solve this problem. So I have x minus 3 over 20 equals 4 over 10, and we're going to cross multiply. So it's going to be 10 times x minus 3 equals 4 times 20, which is going to be 80. We'll distribute the 10. 10 times x is going to be 10x. 10 times negative 3 is going to be negative 30. Add 30 to both sides. We get 10x equal to 110. Divide both sides by 10. And x is going to equal 11. So it's not a bad idea to check our answers. Remember, we had x minus 3 over 20 equals 4 over 10. And if I plug in x minus 3, so if x is 11, 11 minus 3 divided by 20, 11 minus 3 is 8. 8 divided by 20 is going to be 0.4 if I check that in my calculator. And then if I do 4 over 10, which is the other ratio I had, I'll do that in your calculator and get 0.4 as well. So these two things end up being the same. That's just good to kind of check your answer. And the answer is going to be x equals 11. Our next way to prove two triangles are similar is going to be the side angle side. And it's similar to congruency, where the angle has to be congruent. So we're talking about one angle and two pairs of sides. And this reads that if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides that include these angles are proportional, then the triangles are similar. So in this case that I have over here, angle X and angle M are my angles, and my two sides, so if I take XZ here and MP, that means the ratio of XZ to MP needs to equal the ratio of XY to MN. So this is how I would show that they're proportional to each other. Again, you're never going to write XZ is similar to MP. This is wrong. Do not write this down. You're never going to tell me the two sides are similar. The only thing that can be similar are triangles or quadrilaterals or some sort of polygon. We're never going to say two sides are similar to each other. If I want to show proportionality, this is how I do it. All right, so we're going to go ahead and write a proof here. And this is going to be a little bit different than some of the other proofs that we've done. We are given that WV is 4, XV is 5, WY is 8, and XZ is 10. That's all given in my diagram. So what we're going to do is to show that these two triangles are similar, we're going to do side angle side. So the first we should go ahead and do, let's go ahead and show we need a pair of congruent angles. And that's going to come from angle V, which is going to be a shared angle. So angle V is going to be congruent to angle V. And my reason is going to be the reflexive property. Okay, so if we're keeping track here, that's one pair of angles right there. And the only thing now I need is going to be a pair of sides. Now the two triangles I'm looking at are VWX and VYZ. So we want to show that these sides are going to be proportional to each other. So the first thing I need to do is go ahead and define, well, what are these sides? And we're going to use something called the segment addition property to talk about Vy. So Vy is made up of Vw plus Wy. So Vy plus Wy is going to equal Vy. And then the same thing for the other side, Vx and Xz make up segment Vz. And like I said, that's called the segment addition property. The next thing we're going to go ahead and do is we're going to substitute. Let's put numbers in here. Let's figure out how long Vy is and how long Vz is. So the numbers that we have up here in my given statement, we're going to substitute these values into what I just wrote down for number 3. So Vw is 4 plus Wy, which is 8, and that's going to equal 12. Vx is 5 plus Xz, which is 10, and that's going to equal 15. And again, my reason for this is going to be substitution. So now I know how long Vy and Vz are. Vy is 12, Vz is 15. The next step is going to be to set up my ratios. We want to show proportionality. So I want to show that Vw over Vy is going to be the same as the other side. So Vw, we were given, is 4 over Vy, which we just found out to be 12, is going to reduce to 1 to 3. So there's a ratio. At the same time here, let's talk about my other one that I have, Vx over Vz. Vx is 5, Vz is 15, which is also going to reduce to 1 to 3. And again, my reasoning for this is just going to be substitution. All I'm doing is substituting number values in. Now we notice that the ratio for both of these is exactly the same, which is what I want to happen. So since we have Vw and Vy is equal to 1/3, Vx over Vz is equal to 1/3, we can go ahead and say that Vx and Vz are equal to each other. So Vw over Vy is equal to Vx over Vz. And the reason for this is going to be the transitive property. So what I've just done here is I have my two pairs of sides now. So this is one pair of sides proportional. This is the second pair of sides proportional. I have my two sides and my included angle. So we now have enough information to say that my triangles are similar to each other. So the last thing I'm going to go ahead and do here is say the triangle VYZ is similar to triangle VWX, and my reason is going to be side, angle, side. Now this is one way to do it. This is a proof. It's a little bit of a longer proof, as you can tell. But this is being thorough and going through and making sure we're showing everything. The most important part of this proof is going to be this part right here, where I show that ratios are the same. This is the most integral part because we need to make sure that we're showing that the ratios from one pair of sides is the same as the other one. And then this statement right here, where I show that these ratios are equal to each other, is very, very important. So any sort of explanation has to include the statement that these pair of sides are proportional to each other. And this is how I show it, is by showing the ratio of Vw to Vy is the same as the ratio of Vx to Vz. All right, so that's it for these notes. Go ahead and try the You Try Nows on your own. As always, write down questions that you have and make sure you ask them next time we see you in class. Have a good day.